Okay, but let us get into the crux of today's lesson, which is looking at numbers. And today specifically, we're going to look at the number system. I got there in the end. Okay, so a little bit about the number system before we get into it. The number system is basically all of the numbers that we work with. There are two broad groups of numbers that we work with. The ones that, or the numbers that we work with 99% of the time are real numbers. These are the numbers that you encounter every single day, from your fractions to your decimals to your negative numbers, your positive numbers, your square roots, exponents, all of that stuff. Those are your real numbers. And like I say, 99% of the time you will be working with real numbers. Now, we do get a different number system, which is our non-real number system. You don't have to worry about that, but it does exist. Now, for example, just so that you guys can see, there are numbers that we call imaginary numbers, and this part forms part of our non-real number system. Sort of makes sense. Non-real, imaginary. We can't really comprehend what they mean. So if you have a calculator, you can do this with me. If you type square root -1 on your calculator and you push answer, your calculator goes into a panic. Maths error. Can't do it. No, no, no. Square root of -1 is actually an imaginary number and is part of that non-real number system. Now, this is really for later on in life. If you decide you're going to study maths, you'll start dealing with non-real numbers. It's not something you need to stress about now, but it is important to take note of. Another situation where we get this is whenever we divide something by 0. So if I say 6 divided by 0, calculator panics, because remember, that's undefined. It's not something that we can just assign a number to and understand what it's saying. So that's your non-real number system, but you don't have to stress about that. What we want to focus on today is our real number system. Now, most of you would have done this number system before, so I'm actually going to ask you guys to help me out here as we go along. Your number system is basically categories or groups of numbers that we can put different numbers into. Now, some numbers can fall into multiple categories. So you can see here that, for example, this orange block of integers, let's maybe not use a weird colored highlighter. This orange block of integers encompasses or includes whole numbers and natural numbers. And so numbers that are integers can also be whole numbers and natural numbers. So it's just important to understand that, yes, we're grouping or categorizing numbers. Ooh, panic. But numbers can fall into multiple groups. So I'm going to ask, can anyone tell me what natural numbers or a natural number is? What are our natural numbers? Doesn't have to be a beautiful definition. I just sort of want to know, what are natural numbers? Riabetswe, tell me.
Hi, ma'am.
Hi.
Ma'am, so in my way of seeing it, natural numbers are whole numbers that are greater than or equal to 1 and are represented by the symbol of n.
Oh, on it. Well done. I actually quite like that definition. So natural numbers are all numbers that are greater than or equal to 1, but we don't include fractions or decimals there. Another phrase or another term that we can use here are counting numbers. And basically, these are the numbers that you learn to count with. So 1, 2, 3, 4, 5, and so you keep going all the way up to infinity. Right. As Roberto told us, there's a symbol, and for all of these, there's a symbol. The symbol for natural numbers, or to represent natural numbers, is an N. I've tried to do it as best I can, but let's try again. I always draw my N with like a double line in the middle, just because that's generally the font that they use to represent it, just so you can get familiar with it. But basically, a capital N represents natural numbers. And those are all your counting numbers. So from 1 all the way up to positive infinity. Okay, very, very nice. Who can tell me what whole numbers are then? Matthew?
Hello, ma'am.
Hi.
Ma'am, whole numbers are numbers starting from 0 upwards.
Excellent. Well done. So to create some chaos, we decided that we would add a whole new category to just include one extra number. So basically, whole numbers are all of your counting numbers as well as zeros. Now it's 0, 1, 2, 3, 4. And so we keep going all the way up to infinite. Just muted myself, sorry. It's almost exactly the same as your natural numbers, except you now include 0. Now, the symbol for this is very similar because it's basically the same thing. So it's a capital N, but now there's a 0 at the bottom to show that we are including 0 in this whole sequence of numbers. So those are your whole numbers. Now, quickly want to take you to this diagram over here, because you can see here that these whole numbers, we've got a fraction in there, we've got a square root, and this is more just to show you that every answer should be simplified. So 9 divided by 3 is 3. 3 is a whole number. The square root of 36 is 6. 6 is a whole number. And so this is more to show you that when trying to classify numbers, always make sure that you're working with the simplest form of that number. If you're not, you're going to incorrectly categorize it potentially. Right, so those are natural numbers and our whole numbers. Can anyone tell me what an integer is? Lawrence, what is an integer?
It is numbers that are positive and negative, I think.
Excellent. Good. So these are all our positive and negative, I'm going to say whole numbers for lack of a better description, but basically it's all positive and negative numbers that are not fractions. So we're not yet dealing with fractions or decimals. We're still dealing with whole numbers, but now we're dealing with all the positive and negative ones. So think of it like a number line. If I could draw a beautiful number line. Positive infinity, negative infinity, all of your negatives, including 0, up to your positives. Right, very, very nice. Can anyone tell me what the symbol is? Tato, do you know what the symbol for integers is?
Yes, ma'am. It is a Z with a line.
Fantastic, well done. So integers, the symbol is Z. I can't tell you why. It's probably from, I don't know, ancient Latin, Greek, something where maths originated from, but it is a Z. Tato, I just picked on you. Did you have anything else that you wanted to ask or say?
Ma'am, I wanted to answer for rational numbers.
Okay, cool. So Tato's about to tell us what rational numbers are. Don't stress. I'm going to put this all back so that we can take screenshots, Nana. So Tato, tell me what a rational number is.
A rational number is any number in the form of A, B, and A over B, where A and B are integers. All terminating and recurring decimals are rational numbers.
Perfect. Okay, so I'm just going to summarize that a little bit. So the first part of what Tato said in terms of the A and the B, where A and B are integers, etc., etc. Basically, what we're saying there is numbers that can be written as fractions. So if you can write a number as a fraction, it is a rational number. Oh, I don't know if I'm going to fit this in. Let's try and... sorry, everyone. Just move that. So if we can write it as a fraction, awesome, rational number. Now, for example, things like 3, the whole number 3, I can write that as a fraction, 3 over 1. The decimal 0,6 recurring, I can write that as a fraction, 2 over 3. So as long as whatever decimal or whole number, whatever it is that you're working with, you can write it as a fraction, you have got a rational number. Right. The second part of Tato's definition there for us is basically decimals I don't always write this down because I'm quite lazy when it comes to decimals, and fractions for me is easier. Decimals that recur. So basically what that means is they repeat themselves, or they have a pattern. So when I say repeat, that 0.6 recurring that I refer to here is basically 0.6666666. It just keeps repeating itself. Something like 0.123, 123, 123, 123, 123. There's a pattern, it keeps repeating. That's what I mean recur. Or it's decimals that, Tato used the word terminate. Basically, it has an end point. Terminate. I'm going to say end. So for example, the decimal half is just 0.5. It stops there. It doesn't keep going. So if you've got decimals that have a pattern or that recur or that end after a certain point, you have got a rational number. And that's because you can write them as fractions. So for example, if we just go to, sorry, I'm just going to make this a bit smaller. If we go to this value over here of 3.78, that I could write as a fraction as 378 over 100. That does simplify, it's like 180 something. 189 over 50, but I can write it as a fraction. It's not a very nice fraction, but I can. The 1.5 as well, I can write that as 3 over 2. Any fraction or any number you can write as a fraction is a rational number. Okay, Tato, just because I see your hand is still up, what is the symbol for rational numbers?
The symbol for rational numbers is a Q with a line.
Fantastic. So rational numbers is just a Q. Okay. So whenever you see a Q, that is your rational numbers. Okay. Anyone want to try and tell me what then an irrational number is? The lady?
Irrational numbers are non-terminating numbers and the non-recurring.
Okay, perfect. So again, you guys are so on it with the definitions. I've clearly gotten lazy. Naledi said non-terminating, non-recurring. So again, I like to think of it as fractions. I'm going to write that down now, so don't stress. Basically, these are numbers that we can't write as a fraction. Clearly can't talk and write at the same time. We can't write fraction. So there's no possible way for you to write the number as a fraction. It's irrational. Now this is now leading into what Naledi said. These are the decimal numbers that are non-recurring. So basically, they can repeat, but there's no, oh golly, they can repeat, but there's no like pattern to it. And non-terminating. So if they're non-terminating, basically it means that they never end. So I'll say non-terminating / ending. So the decimal just keeps going on forever and ever and ever. Now, a very commonly used example of this is pi. Okay, I don't know why I'm showing you the calculator. That was a weird thing to do. But pi is one of probably the most famous irrational numbers. Pi is a decimal that just keeps going. There's no pattern to it. It just keeps going, keeps going, keeps going. There are like competitions held for people remembering the most number of pi decimals. I googled it earlier. The unofficial record is 100,000 decimal places, which took the person 16 hours to remember. So pi is one of the famous irrational numbers. Often we'll test you on pi. But basically, if you can't write it as a fraction, it's irrational. Now, if you look at the examples in the little pink block there of irrational numbers, say, for example, something like square root 31. If I type that into my calculator, firstly, your calculator will always give you the fraction form if it can. Okay, so here, type square root 31 into my calculator. I can no longer see myself. Let me just make sure I'm showing you the right thing. And it gives me square root 31. Now, what that means is if you push SD, it comes up with this whole long, beautiful decimal, but that decimal is meaningless. There's no pattern to it because this decimal is so long. Now, remember, your calculator can't keep going. It doesn't go on for infinity. This decimal probably doesn't ever end. And so it's non-recurring, non-terminating. So it is irrational. All right. Now, the way you can often check if you're really struggling is, like I say, type it into your calculator. Your calculator generally will always give you the fraction. So type it in. If you get a fraction, cool, it's rational. Right, I see a couple hands. So if your hand is raised, I'm assuming you have a question. If you don't have a question and your hand is still raised, please lower it. So Naledi, Raymond, and Pusiletso. If you have a question, leave it up. Right, Pusiletso, what is your question?
Ma'am, I wanted to give the answer for the symbol for irrational numbers.
Oh, yes, thank you. What is the symbol for irrational numbers?
It's a Q with a line on top.
Perfect. So irrational number symbol is Q with an apostrophe. That apostrophe in maths, it depends what section you're talking about, but can mean not. So it is not a rational number. It is irrational. Thank you. I completely forgot about that. Naledi, do you still have a question? Ah, Naledi left me hanging. I'm joking. It's chilled. Okay. Right, guys. So what I'm going to do is I'm going to make this a touch bigger. Just make sure everything you can still see. No, because that's who I am. Right, I'm going to leave it like that in case you want to take a screenshot. I would take a screenshot mostly because you've got all the definitions here. You've got a little picture there for yourself. It will help you to know what these are. And in terms of as you go up in the grades, we're probably never going to ask you classify the numbers, but knowing the types of numbers you're working with is very important. And so as we start to get sort of more in depth in our sections, knowing that you're working with a rational number is useful to you. So I'm waiting there while I'm doing that. And the lady's got a question of how do we determine whether it is terminating or non-terminating number. So Naledi, this is sometimes quite hard to do, and this is why the calculator trick, for lack of a better word, is quite useful. If you're unsure, I would put the number into your calculator to see if you get a fraction. Now, if we give you a decimal, I would have to either tell you that it keeps going, and I could either do that by, say, giving you a decimal of 3,127,985 and just put 3 little dots, or I would have to say that it is non-terminating. However, if we give you a decimal, you can sort of assume that it ends after the last decimal point. So here, that 3,78, you can assume that it ends at 0.78. Yeah, otherwise, technically anything could carry on if I don't tell you. So we would have to be quite clear about that. Right, I'm hoping we've all got our screenshots. Last 2 seconds. Grand. Right, we are already over halfway, just over halfway. So we're going to take a little brain break. Those of you that know me, you got a joke, you got a brain break. You can enjoy the joke, you cannot enjoy the joke. I take no offense. My jokes are cheesy. I acknowledge that. We accept it. Right. So someone is jamming outside. Your brain break, for anyone who is new, your brain break is basically a little point where you can get up and stretch and just move a little bit to try and get that brain flowing. Yeah, we want the brain flowing, to get the blood flowing to the brain. I know that it is hot. Some of you are in very hot places. Like I feel like I'm a little puddle at the moment. I'm like Olaf from Frozen. It's very hot, and to sit for an hour is intense. It's a lot to ask. So get up, move. If you need to grab some water, if you need to run to the loo, quickly do it. Otherwise, you've got a brain break here. So your brain break here is saying that you've got a large square, which is the square outside here, which I beautifully outlined because clearly I'm very good at outlining things. Is divided into smaller squares. One of the squares has a diagonal drawn, so this is the diagonal over here, and I'm asking you what fraction of the large square is shaded. So have a think. You can put some answers in the chat, or you're welcome to raise your hand. But what portion or what fraction of the square is shaded? You guys have these days where you're so on it, like today, and then I just wonder, I'm like, what? You don't need me. You are like on it. Watu is just looking bright and happy in her yellow. Love it. And I like your glasses. They look very pretty. I'm just putting you on the spot. I'm sorry. When I can see your lovely faces, I love it. Okay, I'm liking what I'm seeing so far. Well done, guys. Half the square, excellent. So in case anyone's a little bit confused about why it's half the square, just so that we can all see what's possible. Also, like Minantle's got a lovely explanation here. I'm gonna give everyone, does anyone want to raise their hand and explain why it's half the square? Mostly because now Minantle has put on a lovely explanation. So I'm hoping someone's going to raise their hand. Ah, Theo, tell me.
Hello, ma'am.
Hello.
So, ma'am, there's the other half on the left side and the other half on the right side. So, if I plus the two together, it gives me a whole plus the other one, which is forward to, then simplify it, which gives us a half.
Okay, cool. So I circled very weird things there. I wasn't actually circling what Theo was saying. So if we go back to what Theo was saying, if we start in this block here, technically each of the shaded bits is a quarter, but because there's two quarters shaded, I've got a half shaded there. Now, knowing that that line was a diagonal is important because we should know that a diagonal cuts a square exactly in half. So the shaded bit here is a half. Now, if we look at this whole bottom rectangle here, technically that is half of the big square. And so we've got one portion of it shaded. And so excuse me, if we've got combined a half shaded at the top and a half shaded at the bottom, that would mean in total only half of my square is shaded. So half a square, well done. I feel like I saw someone, Emmanuel, the ratio method. I love Emmanuel, just is like gem because he loves to come up with new methods. I have no idea what you mean by the ratio method, so I would love to hear what you mean by the ratio method. But as long as you're getting half, I'm pretty happy. I see a hand, Kakiso. Do you have a question for me? Nope. Okay, Emmanuel, ratio method. Tell me.
Okay, ma'am. So I'm not sure if it's actually correct, ma'am. Okay, but I got an idea. So what I did, ma'am, I counted the pieces that were shaded and the pieces that were white, ma'am, and I got four. And then I, yeah, ma'am, that's what I got, ma'am. 4. So I figured that it was half. So yeah, it's not proper, but.
Okay. No, I like that. So the reason this works is because each of these is splitting the square perfectly in quarters, right? And so in this first block here, your 1, 2, 3, 4, it's all proportional. This 1, 2 is exactly a half. And once again here, it is exactly a half of the half square. And so because it's all proportional, absolutely fine. And we know it's proportional because of the fact that we're working with a square here. So that's cool. Love it. Right, guys, this is also like why brain breaks are so cool. You don't have to do it the way I do it. You don't have to do it the way Emmanuel's done it. You don't have to do it the way Theo did it. You do it the way you do it, 9 times out of 10, it's going to be correct. Okay, and that's why maths is so fun sometimes, is because there's so many different ways to do the same thing. I know we don't always feel that way about maths, and that's cool. I won't take offense, but it is really cool. Okay. I don't know if anyone wants to take a screenshot of it, but I'm going to move on away. So if you do it now, and we're going to try classifying some numbers here. All right. So for this first example, if you want to copy down the table, by all means, I'm not going to stop you, but it can be a bit tedious. So you've got 2 options. Option 1, take a screenshot. Option 2 is just write it as the number 6, and then you can write down the group it falls into. Completely up to you. So I'm going to do the first one with you so you can see what it is we want to do here, and then I'm going to ask you to help me with the rest. So if we look at our first number here, we've got the number 6. So I want you to tick in which category it falls. So you can go back to the screenshot you took of this whole number system diagram situation over here. Otherwise, you know your number system. But 6 is a natural number because it's part of the counting numbers. 6 is an integer because it's a positive whole number, which means that it has to fall in the rational numbers. Right, the lady has raised a very good point. What do those letters mean? So just as a reminder, these symbols, these are natural numbers. Z is integers, Q is rational numbers, and Q dash is irrational. I should have started with that, but the lady's on it. Okay, so 6 is a natural number. It's part of our counting numbers. It is an integer. It's a positive whole number, and therefore it is rational. I'll come to this now. Give me 2 seconds. Again, the second you have a natural number and or a whole number and or an integer, they all fall in the rational number basket, which means they automatically are rational numbers. Okay, so who wants to try B? You can put it in the chat, you can raise your hand. B is 2/3. We want to put them in the correct groups. Oopsie daisies. Kaketso, what do you think? Oh, sorry, I need to fall off my chair.
Ma'am, I think B is a rational number.
Excellent, well done. So B is just a rational number because it's a fraction. So it means that I can write it as a fraction. If you go to that decimal definition, which I'm pretty sure Tato gave us the definition for rational numbers. If you type it in on your calculator, you just get 0.66666. Now your calculator does eventually round off to 7 because again, it can't just keep going, but it is a recurring decimal. In this case, non-terminating, but that's fine. It is a rational number. Now, guys, obviously, if it's rational, it can't be irrational. So you will never tick both rational and irrational. Okay. Right, next one, -4. Who wants to try that? The lady's hand is already up. The lady, tell me. I don't know if I actually asked you to unmute.
Ma'am, -4 is an integer and it's rational.
Fantastic, well done. Integer and rational, not a natural number because it's not part of those counting numbers. So only integer and rational. Very, very nice. Okay, D is, I don't know why, I don't know, I'm having a moment. D is pi, just for reference sake, pi. Tell me, what do you think pi is?
Hi, ma'am.
Hi.
Okay, ma'am. So pi is an irrational.
Fantastic, well done. Pi is irrational. The second you tick irrational, you can't tick any of the others because irrational is sort of its own group. Okay, the second you see pi, irrational. Sometimes, guys, we like to mix it up a bit and maybe say 3 pi or like 3 pi over 4 or 3/4 pi. But if you see pi, it is irrational. Okay, anyway. Wonderful. Very, very nice. Okay, e, square root of 4. Now, I'm going to put it out there into the universe that maybe simplify what square root of 4 is. So ask yourself, what is the answer of square root of 4? And once you know that, tell me what you think it is. So Mateo, oh, sorry, I've just unmuted everyone who's not you. Mateo, what do you think it is? Left. Okay, it's fine.
I think
Take it.
it's a natural.
Palesa? Oh, no. Oh, gosh. So, sorry, Palesa, hang on. Mateo, try again.
I think it's an integer and a natural number.
Thank you. Sorry, I don't know what happened there. Okay, so guys, square root of 4, we know is positive 2, which means that it is a natural number, it is an integer, and which automatically means it is a rational number. Very, very nice. Well done. Okay. Oh, Lesa, last one, square root of 5. I'm clicking so many things here, guys. So sorry. I'm gonna take a, yes, tell me.
Square root of 5 is irrational.
Fantastic, well done. Square root of 5, irrational. If you type it in on your calculator, it's just gonna give you this whole long decimal. We can't do anything with it, irrational. Very nice. Sorry, there was a great deal of confusion there on my part. I do apologize. Kulunga, I did see your hand. Don't worry, there's more questions, so you can help me out in a second. I'm just going to give everyone a chance to screenshot before I move on. And guys, just a reminder, always double check that the value that you're working with, you have simplified. If you need to simplify it, do that, because a simplified answer isn't a different answer, it's just a simplified answer. So we always want to work with the simplified one. Okay, I'm moving, do it now. Right. So our next example, quite similar, so nothing too stressful that we need to worry about. You're given a list of numbers now, and I'm asking you some questions. So I just want to make sure that we all understand what these numbers are saying to us. So if we start with the first one, we've got 0, we've got 3,42. Now 3,42, it's got these two little dots on top of the, who knows, I don't know, on top of the 4 and the 2. Those little dots mean recurring. So basically what this number is 3,42, 42, 42, 42, 42, and so it just keeps going. The pattern repeats, so it is recurring. If we then go to negative square root 25, we know that the square root of 25 is 5, but we're dealing with the negative of that. So we're actually dealing with negative 5 there. Pi, we know, is 3,141526, blah, 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 and so it keeps going. 3 over 4 is a fraction. We don't really need to write it as a decimal. If you want to, 3 over 4 is 3/4. So as a decimal, it's 0,75. We then have 2, which is 2. We then have the decimal 0,45, which this goes back to, I think it was Naledi's question. It stops, right? It doesn't carry on after 4/5, so it terminates, which does mean I could technically write it as a fraction as 45 over 100, which definitely can be simplified. Just right now, I can't tell you what that is, 9 over 20. And then we've got 0. Okay, so those are a little English. Those are the numbers we are working with. From that whole list of numbers, I want you to tell me which of those numbers is a whole number that is not a natural number. So a whole number that is not a natural number. Oratile, tell me.
Ma'am, is it 0?
Fantastic. Well done. So guys, remember your natural numbers are your counting numbers. 1, 2, 3, blah, 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 blah. Your whole numbers is in 0, 1, 2, 3. So you're basically looking for the number that is whole, but not natural. The only one that doesn't fall in there is 0. So exactly as Oratile said, 0. Very, very nice. Well done. Okay, next one. An integer that is not a whole number. An integer that is not a whole number. So think about what your integers are. Think about what your whole numbers are. Emmanuel, what do you think?
I say the square root of negative 25.
Fantastic. You said it so much better than me. The square root of negative 25, if you wanted to say negative 5, I'd be okay with that. And this is because if we think about our whole numbers, I've already listed them. Our integers start with negatives, so we want that negative value. And we only have one negative there, which is that negative 5. Very nice, guys. Well done. So what we're going to do, because you're clearly just all on it tonight, is I'm hoping we can all still see, and I need to move this away because I can't see now, is there are 3 more questions. So C, D, and E. I'm going to read them just in case you want me to, but I want you to try those by yourself. I'll give you like a minute, and then I'm going to ask for some answers. So C, a real number that is not rational. Now think about what that means. If it's not rational, it has to be irrational. D, you're probably going to have a list here. All rational numbers that are not integers. And E, a factor of 10. E is a bit of a wild card. It's a bit of a random one. You need to know what factors are. E, a factor of 10. Give everyone a minute or two to give it a try, give it a go, and then we'll have a look.
1 and 5. 1, 2, and 5.
If you need to, go back to those definitions that you screenshotted or that you wrote down for your different numbers. And then give you another 60 seconds or so. Okay. Ooh, right. Keketso, do you want to give us C, a real number that is not rational?
Ma'am, if I'm not wrong, it is the square root of negative 25.
Okay, so remember we're saying if it's not rational, it has to be irrational. So which number there is irrational?
The symbol of P.
Good, well done. So we've got pi over there. I wouldn't try and write it out as like a rounded off decimal, just use the symbol. Obviously pi is, everyone's pi is like a little bit different, but basically 2 lines with a squiggle on top, absolutely fine. Very nice, well done. Okay, Matteo, do you want to give us D? All rational numbers that are not integers.
It's 3,42, 3/4, and 0,45. Yeah, that's all I got.
Perfect. Right, so guys, not integers, it can't be a negative or a positive whole number or 0. So we can automatically ignore 0, 2, and the negative 5, and obviously pi because it's irrational, which means exactly as Mateo said there, 0, sure, I don't know, 3,4 to 3/4, 0,45. Excellent, well done. Okay, last one. Tammy, do you want to give us the last one? Factors of a factor of 10 rather.
Okay, ma'am. So the factor of 10 is 2.
Okay, good. Technically, which other number could be a factor of 10?
Probably -5.
Excellent, well done, fantastic. So guys, technically, -5 also could be a factor of 10. Reason being is because if we said -5 times -2, we know that a negative times a negative is a positive, and so it does give me positive 10. So I'd probably like take a moment, but -5 I would give you, absolutely. The one we would probably give though is 2. Alrighty, so take your screenshot. And guys, these last 2 examples is really how the number system is tested. We give you a table, ask you to tick. We give you a list of numbers, ask you to classify. It's not something that comes up extensively, so I'm not going to give you like a 20-mark question or 10-mark question on it. But it is one where you can get 5 nice, easy marks just by categorizing and classifying your numbers. So knowing your number system, useful. And like I say, as you get up in the grades, whilst I'm never going to ask you to classify it like this, knowing what a rational number is and knowing what it means is very important.